Here we are for the final video for section 3.4, and we're continuing with graphs. Just ran out of time last time. So we're ready for example number 6, which asks us to graph the greatest integer function. There's nothing special that has to be done. There's nothing going on with the x. We don't have to move it up. We don't have to move it left. We don't have to move anything. So it's just the original greatest integer function. And the greatest integer function always starts at 0, 0 and goes over to 1, 0. Then it jumps up 1 until it goes to 2, and then until it goes to 3, and then until it goes to 4, and it keeps on doing that. And then we also have to hit the reverse as well. Make sure that we continue the same pattern going down. And notice that the open circles are on the right, the closed circles are on the left. Now, example number 7, we're actually given a graph of a piecewise function, and we need to write the definition. So we're going to have to find some equations of lines here. So if I look at the left-hand line, I notice that the endpoints are -3, 0, and 0, 4. So the first thing I have to do is I have to find what is the equation of the line that goes through -3, 0, and 0, 4. Well, some quick review would say that means we first of all need to find the slope. So the slope would be 4 minus 0 over 0 minus a -3, which equals 4/3. So the slope is 4/3. And then what we need to do is we need to put this into point slope form. So I'm going to just choose this point and this slope right here, and so we get y minus 4 equals 4/3 times x minus 0. And then just cleaning this up, it's y minus 4 equals 4/3 x. So y would equal 4/3 x plus 4. So that's the first part. That's the one that goes between -3, 0 and 0, 4. Now what we need to do is we need to do the other part, and the other part goes from 0, 0 to 3, 2. And once again, we have to find the equation of that line. So the first thing I'm going to do is find the slope. That is 2 minus 0 over 3 minus 0, or 2/3. And then I'm going to take this point and this slope and do y minus 0 equals 2/3 x minus 0, or in other words, y equals 2/3 x. So that's the equation of the line there. So finally, writing the entire definition, f of x equals, okay, it's going to equal this, 4/3 x plus 4 for a little while. What while? Well, when x is between, or -3, and it could include the value -3, and less than 0. So between -3 and 0 is where that's going to show up. Then it's going to be just 2/3 x whenever x falls between 0 and 3. Now notice a couple things. You cannot have an equal sign here and an equal sign here, because x equals 0 here, and then if x equals 0 here, then we would no longer have a function. The problem is this particular graph, it's really impossible to see which one had the open circle, so I assumed 0, 0, or the origin had the open circle, so that's why it was here. If the open circle would have been at 0, 4, then this equal sign wouldn't have been here, but it would have been down here. And you do need to be very careful when do you put the negative. Now, since it's basically impossible to find out what it is, in this case, either answer would be fine, as long as you didn't have the equal sign here and the equal sign here. If you had it in only one location, either answer would have been fine. In the final example, example number 8, is a word problem, and it's very appropriate to this particular section, and it is very common to have this type of problem. An electric company, we have a monthly service charge of $4.93, and then the per kilowatt service charge, the first 300 kilowatts is 0.11589 kilowatt hours, and over 300 kilowatts is 0.13321 per kilowatt hour. And so the question is, first of all, what is the charge for using 300 kilowatts in 1 month? Well, that would be the $4.93 plus all 300 kilowatt hours at 0.11589. And when we do this multiplying and potential rounding, $39.70 is what that ends up being. Then it asks, what is the charge for using 375 kilowatts in 1 month? Well, that would be the 493. That would be the 300 at 0.11589. But that would be an additional 75 kilowatt hours at 0.13321. Now we already know this amount of it is equal to $39.70. We just got done calculating that. And then if we add in this 75 times 0.13321, it all equals out to be $49.69. So that last 75 was almost $10 right there. Last 75 kilowatt hours. So then it says construct a function that gives the monthly charge for X kilowatts of electricity. Now, these two first questions were here to sort of lead you. Hopefully it's pretty obvious to realize we have one charge as long as our kilowatt hours are less than or equal to 300, and then we have a whole different charge if it's above 300. So that's where we're at. But what we have to do is we have to come up with what are the equations. Well, this one's actually the easy one. If it's 300 kilowatt hours or less, it will be 4.93 plus 0.11589 times K, as long as K represents how many kilowatt hours whenever K is less than or equal to 300. So we've got that much of it. But this one greater than 300. Well, here's the deal. If we would actually carry this out and don't round, this would be 39.697. And so realize this number right here represents the $4.93, and it represents 300 kilowatt hours at this price right here. But then we're going to have to do 0.13321 times what? Well, it's going to be the number of kilowatt hours we had minus 300, because we've already paid for 300 in this location right here. Now, is this an acceptable form as final answer? Perhaps, but it's still pretty messy. So what we'd want to do then is to actually clean this much of it up, and so this would be 39.697 plus 0.13321 K minus, and then we have to do the 300 times 0.13321, and now that equals 39.693. We will leave it right at that, because the 39.697 is the total cost for up to 300, or for 300 exactly, and then all we need is the 0.13321, which, and think about this 75 here, this is 375 kilowatt hours minus the 300. So we'll just stop it right there, and then and this is the final answer. So this is the function f of k equals that.